Well, hello, kiddos. Oh my goodness, it's so good to see you. We are going to be doing Unit 7. Oh my gosh, what is that? I can't even write. Unit 7. There it is. Day 2. My name is Mr. Kraus. But for the next hour, you can call me Mr. Key. But I first got a magic trick for you. Watch this. You watch it. It's so cool. Don't go away. Just watch. It's like magic. It's all gone. Oh my gosh. That's just crazy. Okay, I'm back. Oh, I should have checked. Can you see me? Can you see me now? Oh, yeah, baby. You can see me. You can see me now. You know what I got? I got some coffee. Now, you guys don't even know that's Dunkin' Donuts coffee. It's Dunkin' Donuts. Fresh ground Dunkin' Donuts coffee. It's going to make this so exciting. All right, let's get going. Day 2. How do you think that? Oh, man, it's like extra shiny. Sweet. All right, here we go. What in the world do we have here? Special reference right triangles. These ones are a big deal. Deal. So what we're going to do is we're going to talk about some special right triangles. You know, if it's got an isosceles triangle, that one equals that one. Yes? Okay, here's what we're going to do. We're going to make the hypotenuse 2. Why you say 2? Because I told you. This one's going to be 2 as well, but we'll get to that one in a few minutes. Let's take a look at this one. Let's take a look at this one. Can I get a blow up? There we go. Get a blow up. So I would like you to find out the sides. Go ahead. Pause it for a second. Find the sides. I'm just going to drink some coffee. Why are you guys whining? You waiting for me? God! Waiting for the shiny man to help out. You actually should be able to do this. How about if I do this? I'll give you a hint. This is X, and this is X. Did that help? Well, okay, how about this? You can do the Pythagorean theorem, can't you? X squared plus X squared equals hypotenuse squared, which is 2 squared. Well, if you've got an x squared and I got an x squared, we got 2x squareds. We got 2x squared equals 4. So then we divide by 2, and I get x squared equals 2. Take the square root of both sides. Now, normally I put a plus or minus, but since we're talking about lengths, we really only want the plus. So I get x equals the square root of 2. Square root of 2. And you can check that, you know. The square root of 2 squared plus the square root of 2 squared, does that equal 2 squared? Well, that's, oops. The square root of 2 squared is just 2. Plus the square root of 2 squared, that's just 2. Does that equal 4? Of course, Arinsky. So this isosceles right triangle, the isosceles right triangle, the sides of an isosceles right triangle are the square root of 2 and the square root of 2. Okay, let's talk about this one. A bisected, what in the world? Mr. Johnson would be so mad at you if you forgot what a bisected angle. Bisected meaning. Bisected equilateral triangle. Bisected equilateral triangle. First of all, if it's equilateral, this drawing's a little bit off. That side's 2, and that side's 2, and that side's 2. And we're going to do a bisected equilateral triangle, which means this side over here is equal to this side over here. In other words, this angle is equal to this angle, and this side is equal to this side. Wait, if this side over here is equal to this side over here, then this is a 1, and this is a 1. Wait a second. In an equilateral triangle, aren't all angles 60 degrees? 60 degrees, 60 degrees. So if this is bisected, wouldn't that make this 30 and 30? So what we have here is a 30, 60, 90 right triangle. Now, we're going to ignore this triangle. It's kind of like I don't know, Laney. We like to ignore Laney. Oh, yeah, Laney, I'm talking about you. Ignore you. Omalak, you too. Don't even want to talk to you. Just kidding. Okay, so what do we got here? We got a side that is, I hate that 1. We got a side that's 1. We got a side that's 2, but we don't know what this side length is, so we're going to call that x. And we're going to do a little Pythagorean theorem. We're going to do, wherever my marker went, x squared plus 1 squared equals 2 squared. So this is x squared plus 1 equals 4, or x squared equals 3, or x equals the square root of 3. So square root of 3. So in a 30, 60, 90 right triangle, the sides are going to be 1, square root of 3, and 2. Hypotenuse will be 2. In a isosceles right triangle, in other words, a 45, 45, 90 right triangle, the side lengths are going to be the square root of 2, the square root of 2, and the hypotenuse will be 2. So how is that going to work? So I got to shrink this just a wee bit, just a wee bit. Okay, so yesterday we talked, or in the last couple of days we talked about radian measures, right? We talked a little bit about radian measures. And so what we're going to do here is we're going to do, I got to get my pen, get a better pen. So we're going to find out what is the sine of 30. So, okay, that means we got to use this triangle over here. So this triangle's kind of a mess. So let me clean it up so you can see what I'm doing here. So this is the square root of 3. So if this is the angle we're talking about up here, right? That's the angle we're talking about there. Sine is, okay, we got to remember, some old horse caught another horse tripping on alligators, or whatever you decide to use. So some old horse. So opposite, this would be the opposite. This would be the hypotenuse, obviously. So the sine of 30 is 1/2. Now, what's the cosine of 30? Now, cosine is adjacent over hypotenuse. Again, if you went through and took the time, which we probably should do, and label this, of course, this would be the hypotenuse. This would be the opposite, and this would be the adjacent side. So if I wanted to talk about the cosine of 30, that would be adjacent, square root of 3 over 2. And let's do the tangent of 30. The tangent of 30 is opposite over adjacent, 1 over the square root of 3. Uh-oh, we can't have that. Cannot have that. Can't have 1 over the square root of 3. So we're going to have to rationalize that. So we're going to multiply by the square root of 3 over the square root of 3. So this becomes the square root of 3 over 3. Multiply the numerators, multiply the denominators. There it is. Okay, so let's talk about 45, 45, 90 right triangle. Let me clean up my 45, 45, 90 right triangle. Get all this mess out of here away. Let's talk about this. So this one's, the 45, 45, 90 is a really easy one. If this is our angle, which is 45 degrees, sine is opposite over hypotenuse. Well, if that's the angle, this would be opposite, this would be hypotenuse, and this would be adjacent. Now, why is this the easy one? Because the sine of 45 degrees is the square root of 2 over 2. But so is the cosine of 45 degrees. That's also the square root of 2 over 2. And why do I say that's even easier? Watch this. The tangent is the square root of 2 over the square root of 2, which is just 1. And finally, let's go over here and tackle this one. We're going to do this triangle again. But this time, we're going to use a 60-degree angle. So if I'm going to label this for a 60-degree angle, this is still the hypotenuse. But if we're now talking about this angle right here, this is the opposite. And now this is the adjacent. I hope you guys got good at labeling triangles in algebra or in geometry. So the sine of 60 is opposite over hypotenuse, square root of 3 over 2. The cosine of 60 is adjacent over hypotenuse, 1/2. And the tangent of 60 is opposite over adjacent, which is just the square root of 3 over 1, which is just the square root of 3. Now, I didn't discuss the reciprocal functions on purpose because all we're going to do with these is do a little reciprocation. That's not a real word. I've just made it up, and it sounded cool. So for the cosecant of 30, we're going to take the reciprocal of this, which is 2 over 1, or just 2. For the cosine of 30, we're going to take the reciprocal of this, which is 2 over the square root of 3. But you can't have a square root in the denominator, so we're going to say this is equal to, or going to multiply by, the square root of 3 over the square root of 3, and this becomes 2 square roots of 3 over 3. And the cotangent of 30, and we're going to take the reciprocal of this. But actually what I'm going to do is I'm going to take the reciprocal of this. And that becomes the square root of 3 over 1, or just the square root of 3. All right, now, we're going to go over here and do these. And I'll show you why in a second. The reciprocal of this is 2 over the square root of 3. But didn't we already figure out by doing this work here that that's just 2 square roots of 3 over 3? That's probably behind my head. Now it's way off. Now the reciprocal of this one is 2. And the reciprocal of this one is 1 over the square root of 3, but we can't have that, so we multiply by the square root of 3 over the square root of 3, and so we get the square root of 3 over 3. Now finally this one. We're going to take the reciprocal of this, and that becomes 2 over the square root of 2. But you can't have that, so we got to multiply by the square root of 2 over the square root of 2. This is why we went through rationalizing before. And you get 2 square roots of 2 over, and what's the square root of 2 times the square root of 2? Oh, that's 2. Oh, that's just the square root of 2? So it's just the square root of 2. Well, then what's the reciprocal of this one? Oh, that's just the square root of 2. Now here comes the easy one. What's the reciprocal of this one? The reciprocal of 1 is 1. And so those angles, 45, 30, and 60, are going to be huge-mongous. So 45, 45, any 45, 45, 90, or any 30, 60, 90 all they are is dilations of one another. In other words, they are similar. In other words, all their sides are in the same ratio. I don't know what she wants to be put in here, but the sides are going to be in the same ratio. So I'm going to put same ratio. In other words, not ration. In other words, we're going to have square root of 2, square root of 2, 2, or we're going to have 1, square root of 3, and 2. And you'll see why I'm talking in a minute. So let's talk. Let's see. Here we have a 30, 60, 90 right triangle. Now, if you remember correctly from your geometry days, that the smallest side is opposite the smallest angle. Hold on, I got to take a pause for a second. When I take a pause to stop my recording, I do so drinking Dunkin' Donuts. I got to find my Dunkin' Donuts coffee mugs. I don't have them here. They're in some box somewhere. Anyway, so let's talk about this. Not that this is overly that important, but I want to make sure you understand this. First of all, our hypotenuse is 2. So if this is a 1, which is the smallest side, by the way, the square root of 1 is, or the square root of 3 is like 1.732. This would be like the square root of 1 is equal to 1, right? So this is clearly the smallest side. And if it's in a 1 square root of 3, 2 ratio, that means it's in a 30, 60, 90 triangle. So one of these has to be 30 and one of these has to be 60. Well, since this angle is opposite the smallest side, it has to be the 30. And that makes this the 60. All right, now let's talk about that. We're just going to do a dilation. In other words, we blew it up. The hypotenuse went from 2 to 8, 4 times. So what we're going to do is we're going to try to find x. And the easiest way to do that is 2 over 8 is equal to the square root of 3 over x. And I get cross multiplying 2x equals 8 square roots of 3. Multiply those together. Remember, one's in the radical, one's not. They can't be multiplied together. They can only be put next to each other and multiplied. And then we divide both sides by 2, and I get x equals 4 square roots of 3. Now, some of you are like, well, why'd you do it that way? I was taught a different way. Okay, maybe your teacher does this a different way. I'm going to leave that same answer there because you're going to see it doesn't matter. We're going to do it within the same triangle. So 2 is to 1. Oh, excuse me, 2 is to the square root of 3. You got to use the same sides. So 2 over the square root of 3 is equal to 8 over x. Cross multiply, I get 2x equals 8 square root of 3. And guess what? I get that. Oh my God, it's so fun. All right, here we go. Anytime you see two sides are the same, that means these sides are the same. That means these two angles are the same. That means they are just this is the 45, 45, 90 right triangle. In other words, a dilation. So we label our sides the square root of 2, the square root of 2, and 2. So I want to find, I have the hypotenuse. I want to find the missing side. I'm only going to do this one way, and I'm just going to do it this way. I want to find x. I'm going to find x and y. Wait a second. Aren't they going to be the same thing? Oh, yeah, because this is a dilation of an isosceles triangle, which means this is also isos. I'm just going to abbreviate isos because I got a good chance of spelling isos right and not isosceles. So I'm just going to say isos, and everybody calls them isoses from now on. I'm going to get a tattoo of the word isos. Anyway, let's do this. So we're going to do the square root of 2 over 2. It doesn't matter how you set these ratios up as long as you are consistent. If I'm going the square root of 2 over 2, then I got to go x over 5. I just got to stay consistent. Cross multiply, I get 5 square roots of 2 equals 2x. Divide by 2, divide by 2. No decimals. Just leave it. It's 5 square roots of 2 over 2 equals x. Bam! Do you guys hear that wind outside? I'm shaking it. It's a windy day today. Holy mackerel. We're not even in school tomorrow. All right, so I want to find the exact values of x and y. And here's how we're going to do it. We're going to come over here and we're going to draw our reference triangle. And we're going to quickly draw it. Try to draw it in the same format as this one. See how this one looks? Try to draw this one similarly looking to it. Similarly. Now, you have to remember the hypotenuse is 2. The side opposite the 30 is going to be the 1. And then the other one is just the square root of 3. So it's a square root of 3, 1, and 2. And this would be my 60-degree angle. All right, here's what we got. We want to find, let's go x. So x is to 9. So x, 9, 1 to 2. All right, cross multiply. I get 2x equals 9, or x equals 9 halves. 9 halves is fine. 4.5 would be okay, I guess. Let's try the next one. Y is to 9. Thought I'd change colors. Y is to 9. Y is to 9 as the square root of 3 is to 2. All right, so 2y equals 9 square roots of 3. Divide by 2, divide by 2, and I get y equals 9 square roots of 3 over 2. And that's just fine. Leave it. That's all you got to do. The key is drawing the reference triangle that is very similar to this. You got it? Let's do a few more practice. So this is a, do you see how this is a 45, 45, 90 right triangle? So finding y would be pretty easy. That's just the square root of 6 because it has to be the same as this. So y was pretty easy. But finding x is going to be a little bit trickier. So what we're going to do is we're going to come over here and draw a reference triangle in the same orientation. In the same orientation as my other one. And we're going to label this 2. And you got to remember it. The sides are the square root of 2 and the square root of 2. All right, so if I want to find x, I'll go the square root of 6 over x is equal to the square root of 2 over 2. Now this one's going to get a little funky. All right, so here's what we got. We have 2 square roots of 6, cross multiplying, is equal to square root of 2 times x. Now, let's solve this sucker. So we're going to divide by the square root of 2. Divide by the square root of 2. So what I have now is a problem. I'm going to get rid of this. Hopefully you didn't write as big as I did. What I have now is x is equal to 2 square roots of 6 over the square root of 2. But that's a problem because you can't have the square root of 2 on the bottom. So we're going to multiply by the square root of 2 over the square root of 2. So what I get here is, now because these are both under radicals, I can multiply them. What I get here is 2 square roots of 12 over 2. Well, I can just cancel these. So now I got the square root of 12. But the square root of 12 has a perfect square that go into it. So I can rewrite this as the square root of 4 times 3. So my answer would be 2 square roots of 3. Now, having said all that, there's a much, much, much simpler way. You know how, let me see if I can get over there. You know how I just said because these two were both in radicals that I can multiply them together and get this? Well, you know what else I can do if they're both under radicals? I can also divide them. So maybe you didn't see it right away, but the square root of 2 goes into the square root of 6 3 times. So I end up with x equals 2 square roots of 3. A little bit quicker. Just a wee bit quicker. I'll say now we're going to find the exact value. I'm going to tell you in the second one exact mean in the coordinate plane. Now, and what we're going to do is we're going to draw an angle. We're going to create a triangle. Oops, don't like that. It should say right triangle with the x-axis and label it with our 45, 45, 90 and our 30, 60, 90 reference triangles. So exact value, if you looked up the word exact value in the Krauss-Newman dictionary, it would say no decimals, dummy. No decimals, dummy. Coordinate planes means we're going to have to worry about whether or not things are positive or negative. I'm going to show you how to do that, and I'm going to show you a quick trick and a little mnemonic device for checking that as well. Okay? So, I need to pause just for a second. Okay, so what we're going to do here is we're going to find the exact value of the sine of 2 pi over 3. Now, if you can remember something I taught the other day, you are going to make your life a lot easier. And that is, if it's got a 3, then it's going to have a reference angle of 60 degrees. Because 180 divided by 3 is 60 degrees. Now, let's show you how it works, okay? So you see that I'm not silly. So what we're going to do is we're going to take 2 pi over 3. So pi is 180, and we're going to convert it to degrees. So you're going to convert this to degrees. So if you did that, that's 120. All right, so what I'm going to do, let me make sure I'm recording. Okay. Yes, I'm recording. I already did all this, and now I'm recording it again because I forgot to hit record. So anyway, what we're going to do is we're going to draw in a 120-degree angle. There's our initial side. There's our terminal side. So this angle measure is 120 degrees. But we can't deal with 120 degrees. Our reference triangles are 45, 45, 90, and 30, 60, 90. So what we're going to do is we're going to create a right triangle with the x-axis. Now, if this is 120 degrees from here to here, then isn't this reference angle 60 degrees, which is what I said it was going to be a little bit ago? And if that's 60, isn't this angle up here 30? Now, one of the things we've got to deal with before we label the sides lengths is signs, positive or negative. If I'm going in this direction, that's negative. If I'm going in this direction, that's positive. So as I label this sides, we know that the hypotenuse of this right triangle, now remember, we're talking about this right triangle right here. The hypotenuse is 2. The side opposite the 30 is 1, but because we're going in this direction, it's negative 1. And then this missing side then would be the square root of 3. All right, we got one last thing to do, and that's label it. This is the hypotenuse. This is my angle that I'm talking about. We always use the reference angle. That's 60, so we're going to go opposite over here, and this is my adjacent side over here. Now, if I remember correctly, some old hippie caught another hippie tripping on alligators. I want sine is opposite over hypotenuse. So we've got the sine of 2 pi over 3 is equal to opposite, which is the square root of 3, over the hypotenuse, which is 2. Now, that was a lot of work. It looks like a lot of work. You're going to get really good at this. Bam! You're going to write a triangle in the right quadrant. Bam! You're going to write get the reference angle really quick, and then we can be done. Okay. So anytime you see a 5, your reference angle is probably going to be 45 degrees. Probably. So what we're going to do is we're going to draw that 225 degree angle. There's my initial side. There's 90. There's 180. And here's the rest of it right there. A little bit smaller pen. Okay, so that's 225 degrees. But we're not going to deal with the 225 degrees because there's not 225 degrees in a triangle. And this is right triangle trigonometry. So we need to deal with a right triangle. So there's my right triangle. Now, if that's 225 degrees, that means this reference angle is 45. That means this is also 45. All right. Now what we're going to do is label it 2. And if you remember, the sides are the square root of 2 and the square root of 2. All right. So I want to know the cosine of 225. Well, I remember cosine is adjacent over hypotenuse. Wait a second, Kraus. Sines, positive and negative. We did not deal with that. We're going in this direction. That makes this negative. We're going in this direction. That makes this negative. Oh, okay. Now let's label it opposite, adjacent, and hypotenuse. Here's my hypotenuse. Here's my opposite. Why? Because it's opposite the angle. We always use the reference angle. And here's my adjacent side. So adjacent, negative square root of 2 over 2. Now what you're thinking is, wait a second, you just found the cosine of 45 degrees, but I wanted the cosine of 225 degrees. Well, the cool thing about the calculator I have, which is a little bit different than the one you have, is it will show you the exact value. So what we're going to do is we're going to come over here, and I'm going to do cosine of 45 degrees. Now the cosine of 45 degrees is square root of 2 over 2. The cosine of 225 is negative square root of 2 over 2. Now your calculator won't do this. It would be nice, but it doesn't. How about the cosine of 135? Now 135 would be a triangle in this quadrant over here. What would that be? Well, that's negative square root of 2 over 2. Now, the next one I'm going to try is down here, which you may or may not know is 315. So if I do the cosine of 315, notice they're all the square root of 2 over 2, 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 square root of 2 over 2. No matter what I pick, they're the square root of 2 over 2. Did I not do 135? I thought I did 135. But the only difference is whether or not they're positives. Here, they're all square root of 2 over 2, but one of them is positive, one of them is negative. And what it determines is what quadrant you're in. So what I'm going to show you is a little bit trick, a little mnemonic device to remember things. And it's very simple. You just remember all students take calculus. So all students take calculus. Now, what in the heck does that mean? Well, that's very simple. All things are positive in this quadrant. All things. Cosine, sine, all 6 of them. Tangents, cotangents, secants, cosecants, everything. In this quadrant, because it starts with s, sine, and its reciprocal function cosecant are positive. In this quadrant, because it starts with t, tangent, and its reciprocal function, cotangent, are positive. And obviously then this is c, so cosine and its reciprocal function, secant, are positive. So in this question over here, it was a cosine, wasn't it? It was a cosine in the third quadrant. In a cosine in the third quadrant, this is tangent, all students take. So tangent and cotangent will be positive here, but everything else is negative. All right, let's talk. 330 degrees. Let's get 330 degrees in. So there's my initial side. 330 degrees. But I don't have a triangle with 330 degrees. I can only work in a 90, less than 180 degrees. So we're going to work with a reference triangle. So what we're going to do is draw a reference triangle in. Now, if this is 330 and there's 360 degrees in a triangle, in a circle, doesn't that make this 30? And doesn't that make this 60? And we know we made a right triangle, even though it doesn't quite look like a right triangle. It is. So let's label it. Hypotenuse is 2. Opposite the 30 is 1. Opposite the other one is the square root of 3. But now we got to worry about direction. In this direction, it's positive. In this direction, it's negative. All right? So, cotangent of 30. So, some old horse caught another horse taking oats away. So, it's the reciprocal of this one. So, I want A over O. So, the cotangent of 330 degrees. Oh, I haven't labeled the thing yet. Adjacent, or hypotenuse. Opposite. Adjacent. A over O, the square root of 3 over negative 1. Well, that's just negative square root of 3. Done. Moving on. Oh, now, if it divided by 4, that means it's going to be a reference angle of 45 degrees. Guaranteed 45 degrees. All right, let's talk about 7. So 7 times 180 over 4. So 7 times 180, enter, divided by 4, is 315 degrees. So we're going to be back in that fourth quadrant. $315 degrees. And just like I promised, our reference angle looks like hell. Man. Okay, I think we went a little bit too far past. Here's our 315. But our reference angle is going to be a reference triangle of 45 degrees. So this will also be 45 degrees and 90 degrees. Now, wait a second. Cosecant, that's the reciprocal function of sine. So all students, sine would be positive here. That means my answer has to be negative. A quick check. I know that my answer, whatever it turns out to be, is going to be negative because sine is only positive here and cosecant is positive here. All right, so let's get this thing labeled. Hypotenuse is 2. That makes this the square root of 2 and this the square root of 2. So let's see. Some old horse. So that means cosecant is horse over old. We're reciprocal. So, so this is my hypotenuse. This is my opposite. We're always using this angle right here. Opposite and adjacent. So H over O. 2 over the square root of 2. Wait, I didn't see how I already forgot? See, oh, and I'm looking, oh yeah, negatives. I forgot to deal with signs. Isn't this one right here supposed to be negative? This one right here is positive. This one here is negative. All right, so can't leave it like that. So we're going to multiply by the square root of 2 over the square root of 2. So I get negative 2 square root of 2 all over. Now square root of 2 times the square root of 2 is just a 2. The 2's cancel, and I get negative square root of 2. Shwing. Man, this is good stuff. All right, here we go, kids. All right, you know it ends in a 5. Wait, all students take calculus. Ends in a 5. That means my reference angle is going to be 45 degrees. I know it is. Now, 135 degrees. Let's get smart. Here's what I'm going to tell you. I want you to learn to draw a bow tie. See how I drew that? First right triangle. Second right triangle. Third right triangle. When I work with sine, cosine, and tangent, and I want exact values, I'm going to work with one of these triangles. One of them, okay? Now, I want 135 degrees. Well, that means I'm going, this is 90. What did I pick? This is 90 degrees, and this is 180. So wouldn't 135 degrees be in this quadrant somewhere? So I want this triangle right here. So the rest of it, I don't want. Get rid of it all. I only want this triangle. This is the one I want. Now, if that makes this 135 degrees, what's left over is 45. Now, this isn't a great triangle, but I know it's a 45, 45, 90 right triangle. In other words, my hypotenuse is 2, and each of my legs are the square roots of 2 and the square roots of 2. So secant, oh, wait a second, we're in this quadrant. This is negative. So secant is the reciprocal function of cosine. So cosine is adjacent over hypotenuse. That means secant is hypotenuse over adjacent. So if I want the secant of 135, I got to label this thing. Hypotenuse, opposite, adjacent. This is adjacent over hypotenuse. So I want hypotenuse 2 over negative square root of 2. Well, didn't I just on the last problem realize that's just negative square root of 2? Because if I go over in that last problem, that's exactly what it is. All right, moving on. 7 pi over 6. If we divide by 6, 30 degrees will be my reference angle. Let's figure this out. 7 times 180 over 6. Now, if you put that in your calculator, you're going to find out that you're 210 degrees. So again, I either want this triangle, or I want this triangle, or I want this triangle, or I want this triangle. We like to call this the bow tie. Looks like a bow tie. See how it looks like a bow tie? Draw a bow tie. Now, 210 degrees. This is 180. This is 270. That means I'm in the third quadrant. That means I want this triangle right here. Now, this is 210. And this is 180, so that makes this 30. And I just told you, if it divide by 6, it's going to be a 30-degree reference angle. This is 60, and this is 90. So let's draw in our sides. Hypotenuse is always 2. Opposite the 30 is 1. And opposite the 60 is the square root of 3. But we got to deal with signs. We're in this quadrant, so that's negative. And we're also in this quadrant where that's negative. So they're both negative. Now, wait a second. Tangent, I should know the tangent, the tangent's going to be positive in this quadrant, right? So the tangent of 7 pi over 6 has to be positive because all students take calculus. Tangent is positive down here. So let's see if that's right. Tangent is opposite over adjacent. Negative 1 over negative square root of 3. Well, two negatives make a positive. And then we got to rationalize this. And we've already done this once. We're going to multiply by the square root of 3 over the square root of 3. You're going to get good at this. This is equal to the square root of 3 over 3. And there's your answer. Evaluating expressions, exact values. You still need to draw triangles in the quadrant. So, yeah, here we go. Find the exact value of this expression. Okay, so we're going to do this one here. Sine of 315. 315 is in this quadrant. So we're going to draw a right triangle in this quadrant. It's this part of the bow tie. It ends in a 5, so that's a 45-degree reference angle. Now, if you don't believe me, that's 315. Add 45, you get 360. So that's 2 square root of 2, square root of 2, and the square root of 2. Deal with your signs. This one has to be negative. All right. So the sine is opposite over hypotenuse. Opposite over hypotenuse. So this is negative square root of 2 over 2. By the way, what does exact value means? It means don't use your calculator, and I don't want a decimal dummy. Put this in parentheses. Tangent of 45 degrees. Oh, that's nice. 45 degrees is in the first quadrant. I don't have to worry about signs at all in the first quadrant because everything's positive. 2 square root of 2 square root of 2. Tangent is opposite over adjacent. The square root of 2 over the square root of 2, which is just 1. So the answer to this question is negative square root of 2 over 2. Let's move on. Find the exact value of this expression. Oh, wow. Do you see this thing right here? This thing's right here causes kids all kinds of problems. So I need to explain something to you. I'm going to blow this sucker way up if I can. Oh, that's as high as I can go. All right, so here's what you need to know. If you see this, by the way, this is read sine squared of x. But what it really means is the sine of x squared. So sine squared x. What this really means is, and what this is equivalent to, is the sine of x squared. So when I go back over to this thing, and I see this, which looks really complicated, here's how I'm going to rewrite this. First of all, I know everything comes out to be fractions, so I'm going to make this 4 over 1. Whatever this is, I'm going to square it times the cosine of 300. So sine squared of 45. So it's really the sine of 45 squared. So I'm going to find the sine of 45. Well, we've already done that a couple of times, but let's do it again anyway. 45 degrees in the first quadrant. 2 square root of 2 square root of 2. Remember, this is 45 degrees. We know this is opposite, hypotenuse, and adjacent. So we know that the sine of 45, we've talked about it a bunch, is the square root of 2 over 2. Cosine of 300, that's a little bit different. We got to deal with that crap. Now, 300 degrees is in the fourth quadrant. So we're going to go in the fourth quadrant. So if this is 300 and all the way around is 360, doesn't that make this 60 degrees? Oh, sure does. That makes this 30, still 90. Label this sucker. Hypotenuse is 2. The side opposite to 30 is 1, and the side opposite to 60 is the square root of 3. Deal with signs. This is negative. Now, I want cosine of 300, right? Cosine is adjacent over hypotenuse. So this is opposite, this is adjacent, and this is hypotenuse. We're also in this third quadrant, right? All students take calculus. Cosine is positive here. All right, so the cosine of 60 degrees is 1/2. So now what do I got to do? I got to deal with this. So I've got 4 over 1 times. Now the square root of 2 over 2 squared is 2 over 4, right? Because the square root of this squared is 2, and this squared is 4, times 1/2. So let's multiply the tops. I get 8. Let's multiply the bottoms. I get 8. So the answer to this one is 1. Looks like it's 1. Moving on. Is that it? Oh, I thought it was it. Do we have one more? I thought we had one another. Oh, there's where I'm supposed to do all my work. Oh, good. I got work. Oh, good. I got space for work here. We're going to do 2 more problems. So I'm going to rewrite this as the tangent of 30 squared times the secant of 120. In other words, whatever this is squared times whatever this is. All right, so let's deal with the 30. 30 is in the first quadrant. 30, 60. Opposite of 30 is 1. Hypotenuse is always 2, and the side opposite is square root of 3. So tangent is opposite over adjacent. So opposite, this is hypotenuse. This is opposite. This is adjacent. Opposite over adjacent would be 1 over the square root of 3. And I'm going to leave that for now. At the end, if I have a radical in the denominator, I'm going to get rid of it, okay? 120. 120 is in the second quadrant. So I'm going to draw a triangle here. So if this is 120, that makes this 60. That makes this 30. Now, we've got to deal with signs. Because we're in anything other than the first quadrant, we have to deal with signs. This is 2. Opposite to 30 is 1, but because we're going in this direction, it's negative 1. And opposite to 60 is the square root of 3. So the secant, wait a second, secant is the reciprocal function of cosine. Cosine, I know, is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So there's the hypotenuse, there's the opposite, and there's the adjacent. So secant is hypotenuse over adjacent, 2 over negative 1. All right, let's see what we got here. If I square this, and square this, right, because I'm squaring it, I get 1 over 3, right? Isn't the square root of 3 squared just 3? Times negative 2 over 1. I don't like leaving negatives in the denominator. So my answer is negative 2 thirds. Now, I'm going to show you real quick how to punch this in the calculator so you can check this one. So watch this. You got to be real careful. You have to you can't type it in this way. Your calculator doesn't understand it. You got to put it in like this. So I'm going to do tangent of 30. But notice it already has parentheses. So I needed to put parentheses around that. So tangent of 30 squared times the secant of 120. Negative 2/3. Kind of nice. Kind of nice. All right. A lot of times it's just going to turn out to be a decimal, so that's not going to work. All right, 225, that's in the third quadrant. And because it ends in a 5, it's going to be a 45, 45, 90. So that's the square root of 2, square root of 2, and 2. But we're in the negative direction and negative direction. Let's see, cosecant is opposite of sine. Sine is opposite over hypotenuse, so this is hypotenuse over opposite. Let's label this sucker. Hypotenuse, opposite, adjacent. So the cosecant of 225 is 2 over negative radical 2. And again, I'm going to leave that the way it is. At the end, if I have a radical in the denominator, then I got to rationalize. All right, let's do secant of 150. Secant. Secant is the opposite of cosine. Cosine is adjacent over hypotenuse. So this has to be hypotenuse over adjacent. Now 150, that's not quite 180, so that puts us in this quadrant. Again, remember, we're going to draw one of these 4 bow tie triangles. Don't use anything but the bow ties. All right, so this is 150. That makes this 30. That makes this 60. 2. Opposite to 30 is 1. Opposite to 60 is the square root of 3, but it's negative in the negative direction. All right, let's label this baby hypotenuse. This is the opposite, and this is the adjacent. So hypotenuse over adjacent. Hypotenuse over adjacent. 2 over negative radical 3. All right, so we're ready to go. 2 times 2 is 4 over negative radical 2 times negative radical 2 is radical 6. Notice it's positive. Can't leave it like that, so I'm going to have to multiply by the square root of 6 over the square root of 6. So I get 4 square roots of 6 over 6. Can't leave it like that because 2 goes in here twice and 2 goes in here 3 times. So I end up with 2 radical 6 over 3. Now, here's how I'm going to check this. So let's go back to the original. I'm going to show you a quick way to check your answers. And nobody seems to take me up on this, but you should do this. So the cosecant, what is it? The cosecant of 225. I got to put a decimal in because I think that'll make it a decimal. Times the secant of 150 is 1.63. Notice it's positive. So now I'm going to put my answer in. Control division. And I believe it was 2 square roots of 6 over 3. Now hopefully these are the same exact decimal. They are. I got it right. Including the sign. That's a nice little check. All right, kids, that's it. Oh my God. That was a lot of fun and a lot of work. Hope you enjoyed it. Here's looking good. Have a good one, kids. Man, we got a lot of work out of that one. That was a lot of work. Whew, gonna have to move during that day. All right, kids, take care. Catch you on the flip side. Hit subscribe. Bye.